Synaptic pruning in autism, ADHD, and AuDHD. How our brains wire and rewire. Brought to you by the neurodevelopment.org. First, what is a synapse? A synapse is the tiny gap between two nerve cells, neurons, where they communicate. Signals travel across this gap using chemicals called neurotransmitters, allowing the brain and body to send messages. A neuron is a nerve cell that sends and receives information in the brain and body. It has three main parts. Cell body, soma, contains the nucleus and keeps the neuron alive. Dendrites, branch-like structures that receive signals from other neurons. Axon, a long fiber that sends signals to other neurons through synapses. Neurons work together to process thoughts, movements, and sensations. Your brain is a constantly evolving network, shaping itself through a process called synaptic pruning. But what happens when pruning doesn't go as expected? Today, we'll explore how synaptic pruning works and how it differs in autism, ADHD, and AuDHD, which is autism and ADHD combined. Synaptic pruning is like trimming a tree. Your brain removes weak or unused connections so that stronger ones can thrive. This happens multiple times in life, but during early childhood and adolescence, the pruning is more extensive. However, synaptic pruning continues at a lower level throughout adulthood based on experience and learning. The brain is always adapting, strengthening important connections while letting go of unused ones, like decluttering your mental hard drive. In early childhood, your brain rapidly forms new connections, but not all are useful. Pruning helps refine skills like language and movement. In adolescence, another wave of pruning happens in the prefrontal cortex, the area responsible for decision-making, focus, and impulse control. This process is essential for learning, memory, and cognitive efficiency, but what happens when pruning is altered? Let's look at autism, ADHD, and AuDHD. In autism, synaptic pruning does not happen enough, leaving the brain over-connected. This can create both strengths and challenges. Enhanced detail and focus. Autistic brains process more information at once, leading to exceptional pattern recognition, deep focus, and unique problem solving. Sensory overload. Too many connections make it harder to filter out background noise, leading to sensory sensitivities and overstimulation. Social processing differences. Extra neural activity means social cues may take longer to process, making interactions more complex. Imagine having too many tabs open on your computer. Your brain is processing everything at once, making some tasks harder to manage. Now let's look at ADHD. Here, pruning happens too aggressively in areas that regulate attention, impulse control, and working memory. Inconsistent focus. The brain craves constant stimulation, making sustained attention difficult. Impulsivity and hyperactivity. With fewer brake system connections, reacting without thinking is more common. Difficulty with organization and memory. Over-pruned pathways in the prefrontal cortex make planning and prioritization harder. Think of it like a road system with missing bridges. The brain struggles to connect thoughts efficiently, leading to executive function challenges. Now, imagine a brain where some areas are over-pruned while others remain under-pruned. This is what happens in AuDHD when someone has both autism and ADHD. Cognitive contradictions. You may hyper-focus on topics of interest but struggle with executive function for daily tasks. Sensory sensitivities plus impulsivity. Your brain notices everything but also seeks more stimulation, leading to sensory-seeking behaviors or burnout. Social and emotional complexity. Autistic processing may make social interactions draining, while ADHD impulsivity can lead to blurting out thoughts before considering the impact. It's like driving a car with one foot on the gas and one foot on the brake, constantly shifting between focus and distraction. Understanding how synaptic pruning shapes the brain helps explain why neurodivergent individuals think and experience the world differently. Instead of forcing a one-size-fits-all approach, we need to create supportive environments that play to neurodivergent strengths, whether in education, work, or daily life. Want to learn more? Visit the neurodivergentbrain.org for more free resources. Don't forget to like and subscribe.